Hello friends, today we'll start problems. First problem is the first line of Balmer series. The first line of Balmer series of hydrogen atom has a wavelength of 6563 angstrom. Calculate the wavelength of the second line of the Balmer series. Okay. Solution. For Balmer series, you know that 1 upon lambda is equals to r into 1 upon 2 square minus 1 upon 2 square minus 1 upon n square, where n is equals to 3, 4, 5. For first line n is equals to 3. Therefore 1 upon lambda 1 is equals to r into 1 upon 2 square minus 1 upon 3 square. Solve this. So lambda 1 is equals to 36 upon 5 r. 36 upon 5 r. This is the lambda. For second line, n is equals to 4. Therefore 1 upon lambda 2 is equals to 1 upon 2 square minus 1 upon 4 square. Okay. Solve this. Lambda 2 is equals to 16 upon 3 r. 16 upon 3 r. Solve this. Lambda 1 upon lambda 2. Lambda 1 upon lambda 2. Lambda 1 upon lambda 2. Put this value. Lambda 1 and lambda 2. 36 upon 5 r into 3 r upon 16. 3 r upon 16. Solve this. Lambda 1 upon lambda 2 is equals to 108 upon 80. 108 upon 80. Therefore, calculate the lambda 2 is 80 upon 108 into lambda 1 is equals to 80 upon 108 into wavelength is 6563 angstrom. Okay. Solve this. Calculate this value. So we can write 4861.5 angstrom. This is the value of wavelength. This is the value of wavelength of the second line of the Balmer series. Okay. Second problem. Second problem is the series limit. Problem second is the series the series limit wavelength for Balmer series of hydrogen spectrum is 3645 angstrom. Calculate the value of Rydberg constant. Solution. In hydrogen atom, the wavelength of spectral line is given by 1 upon lambda is equals to r into 1 upon p square minus 1 upon n square. Okay, for Balmer series limit, the transition is formed n is equals to infinity to p is equals to 2. For Balmer series limit, the transition is from n is equals to infinity to p is equals to 2. N is equals to infinity to p is equals to 2. Therefore, the wavelength is given by 1 upon lambda is equals to r into 1 upon 2 square minus 1 upon infinity square. Solve this. 1 upon lambda is equals to r upon 4 because 1 upon infinity is 0. This term will be 0. So 1 upon 2 square is 4. So r into 1 multiply. Okay, r into 1. So r and 2 square is 4. So 1 upon lambda is equals to r upon 4. Therefore r is equals to 4 upon lambda. Rearrange this term. So 4 upon lambda, put the value of lambda means wavelength 3645 into 10 raised to minus 10. This value is wavelength. Okay, so calculate this value. R is equals to 1.09788 into 10 raised to 7 into 10 raised to 7 meter per. Okay, this is the value of Rydberg constant. This value is Rydberg constant. Thank you.